Alright class, in this video we're going to do simple trig equations. So when I say simple, it's trig function equals number. Okay? So I'm just going to talk about them as I go through them. So here's an example. So sine of x equals a half. That's well within the range of sine, so it's not an extreme value. That's important to note. So what we're expecting here is two generating angles. Okay? So where is sine positive? It's positive in quadrant 1 and 2. Okay, and if we just do inverse sine to get a value, by the way, just doing arc sine only gets you one value. It doesn't get you all of them. Okay, arc sine has a range, and it's the fixed domain of sine that it uses. So don't just do arc sine and think you have everything. So the reference angle here is pi over 6, because sine of pi over 6 would be equal to 1/2. Okay, that is in the first quadrant. So here's how we're going to write our answers. We're going to say pi over 6 plus 2k pi. That's all the answers that would go along with pi over 6. The second quadrant angle, we subtract pi over 6 from pi. And that would give me 5 pi over 6. And there we have it. That's all the possible answers you could have for that particular equation. Alright, let's do one a little bit more complicated. So cosine of x equals negative root 2 over 2. So once again, let's think in terms of quadrants. So this would be, cosine is going to be negative in the second quadrant and the third quadrant. Okay, and what's my reference angle for root 2 over 2? It's pi over 4. Okay, so how do I do this? I figure out what's the equivalent of pi over 4 in the second quadrant. We subtract from pi to do that. So that would be 3 pi over 4 plus 2k pi. And then the third quadrant, we would add pi over 4 to pi, and we get 5 pi over 4 plus 2k pi. Okay, a little bit more complicated. When you have sine or cosine equal to 0, you end up with sort of a special sort of answer. So it turns out that the zeros of sine and the zeros of cosine, because these guys are periodic, are evenly spaced out. So if I just think about, the graph of sine, got one there, one there, one there. Those are equally spaced out. Those are all pi apart. So if I just figure out the first one, 0, I can just say 0 plus k pi, and I'll have all of my answers. For cosine equal to 0, you'd have to say pi over 2 plus k pi, and that would be all of your answers too. You can, if you want, think 0 plus 2k pi and pi plus 2k pi, but really this is the same answer. Okay? There are special values for sine and cosine, the maxes and mins. So these only happen once from 0 to pi, so you're not going to have two generating angles. So, where is cosine equal to negative 1? You can just think of yourself as a unit circle. Remember, cosine is the x values. Where is the x value on that circle equal to negative 1? It's right over here. So that would be pi, not pi, right over here. No, I had it right. I'm sorry. Pi plus 2k pi. Got myself confused there for just a second. All right. If we go to tangent, tangent's a lot nicer than sine or cosine because you don't really have to worry about quadrants. So if tangent of x equals root 3 over 3, so my reference angle for that would be pi over 6. Tangent of pi over 6 is root 3 over 3. So if there's a minus sign in front, you just put a minus sign in front of your reference angle and you're done. Okay? So in this case, there's no minus sign, so it's going to be pi over 6, but the period of tangent is pi and not 2 pi, so we just say k pi, and that's actually all the possible answers we would have. If you think about it, tangent's positive in the first and third quadrant, that actually includes both of those. Okay? If we have a non-sine, cosine, or tangent trig value, that sometimes can cause us a little bit of distress. Just think about it in terms of what it's equal to in terms of those. So cosecant 1 over sine. Okay, and I'm just going to take the other side and make it into a fraction. And then I can flip both sides here. Take the reciprocal of both sides. And I get sine of x equals a half, and I'm not going to do that one because I already did. That was example 1. Okay? And then, what if you have something that doesn't have a common value? So far, everything we've looked at, we could get an exact value for. But here, if sine of x equals negative 0.3, that's not something that's a common value for sine. We still think about it in the same way, though. So this would be sine is negative in third and the fourth quadrant. Okay. So what I want to do is I want to get a reference angle for these. Okay. I'm not going to worry about the minus sign. I'm just going to think of arc sine. So I go on my calculator, my handy dandy calculator. I do inverse sine of 0.3, and my calculator told me that's 0.305 roughly. Okay. So that's my reference angle. That's not one of my answers because it's in the first quadrant. And my two quadrants are third and fourth. Okay? So, once again, how do I get my third quadrant angle? So I would take my reference angle and I would add pi and then plus 2k pi. And that gives me I should be saying approximately equal to, sorry. Not copying it down right, 3.445 plus 2k pi. Okay? And then, how do I get the fourth quadrant angle? I do 2 pi minus my reference angle. And when I did that, so let me write that down, 2 pi minus 0.305, and that's plus 2k pi. What did I get there? I got 5.978 plus 2k pi. And that's how you need to write your answers if you have something that requires a calculator. All right.